Hi all, Dr. Clark here again. Today for Gen Bio we're going to talk about primate evolution. So we talked about just general evolution, and now we're going to talk about human evolution and the evidence for human evolution. But before we get to Homo sapiens, humans, we're going to talk about primates. And so how did things that we lump in primates, in the group primates, how did they evolve? So how did lemurs and tarsals and New World, Old World monkeys, orangutans, chimpanzees, how did they evolve? When did they evolve? What's the evidence for their evolution? Okay. And as time goes, as we get better at paleontology, as we get better at genetics, as we get better at doing just general science, the evidence for primate evolution, human evolution, just keeps increasing, and we get more and more data. For example, it wasn't too long ago that we found Ida, which is the oldest known ancestor to primates. Okay? And we don't know yet where Ida fits. If Ida is, part of the monkey line, okay, or if Ida is part of what we call the lemur line. And so we're not sure yet. They have Ida, this fossil has characteristics of both. And so with really every passing year, or even every passing couple months, we have a new piece of evidence that comes out, new fossil discovered, new fragments of teeth or something along those lines discovered in different regions, because we're getting much better at knowing where to look, and for that matter, knowing what to look for. Okay? All right, so we're going to go through and talk about primate evolution. So first of all, it starts about 65 million years ago. That's where human, or the path to human evolution, begins. Okay? That doesn't mean that humans are 65 million years old, and it's not even close to that. Okay? But the primate line starts about 65 million years ago. Okay? Arconta, okay, was an arboreal animal, or mammal in that perspective, okay, placental mammal. And arboreal meaning that it climbed or it lived in the trees. Okay, so it would have adaptations to tree life. Okay. Because it had adaptations to tree life, we can see things like opposable thumbs, but we can also notice that based on the eye sockets that it was a nocturnal arboreal insectivorous organism. So there's a couple things that we'd be looking for. If it's nocturnal, you know that it has large eyes. We know that from other species that are nocturnal. Arboreal means it probably has either grasping hands or at least a grasping tail. If it's insectivorous, okay, it means that it probably has puncturing teeth. Now, through this line, it gave rise to a lot of other mammals. So this is kind of the beginning of, this adventure of primates into the trees and into the livelihood of being insectivorous, and then eventually being omnivorous and eating both plant and animal products. Okay. Now, we know that this Acantha gave rise to a few different lines. Okay? A line that was the tree shrews, which still exist, okay? And they are mammals without prehensile hands, so they're still arboreal, so they climb, but they walk on all fours. They are insectivorous, okay? And most likely they gave rise to bats. And so some of the shrews probably developed skin flaps, which allowed them to glide, and eventually the skin flaps became, more advanced, and they could flap their wings or flap their hands in that case, because bats are finger-winged organisms, and eventually you have bats. But the other line is primates, these organisms that stayed in the trees and gave rise to all the other mammals along the primate line, all the monkeys and the lemurs and chimpanzees and gorillas and humans. And so about 65 million years ago is when this kind of branching or this line started. Now, primates themselves are mammals that have two really distinct features. Okay? And the distinct features that allowed them to succeed in an arboreal environment, in a tree-dwelling environment, were one, they have grasping fingers and toes. Okay? And so some were opposable, okay? So they had the ability to move like our opposable thumbs. But all of them had grasping capabilities, and they had some kind of fingernail, some kind of nail that was attached. Okay? So the grasping finger and toes is a huge environmental advantage. And then the second one is binocular vision. The reason why all primates have eyes in the front of their head is so that their eyes can focus on a single object. Okay? By having binocular vision and focusing on a single object, you can judge distance. Okay? Now, there's advantages clearly to judging distance, especially if you're trying to capture prey like insects and things like that, or make a jump from one branch to the next. You can judge the distance. Okay? There's a huge disadvantage also. It's harder to detect predators. Okay? But because you're arboreal and you live in trees, predators normally come, from a visual point of view. They're not going to sneak up from you on all sides. Okay? Most likely you'll see the predator coming. When you look at organisms that develop outside of trees, okay, like on grasslands and things like that, like ungulates, so like antelope or deer, elk, moose, whatever it is, their eyes are actually on the side of their head. Okay? They don't judge distance in front of them very well, and some of you hunters probably know this, okay? But they do have the ability to see even a little bit behind them, predators coming. So they have this vision, this kind of more of a lateral vision than a binocular vision. Okay? Now there's advantages and disadvantages to both. Clearly binocular vision is an advantage if you're trying to pinpoint some jump or some insect or something. So 40 million years ago or so, primates split into two main groups. You have the persimmons, which are survived or have remnants of this group, are tarsers and lemurs and lorises, okay? And a lot of these are really endangered groups of primates, but nonetheless, they occur in regions, specialized regions a lot, okay? Like places like Madagascar, where you're going to find lots of lemurs and things like that, because they've been separated for a very long time, probably prior to, Madagascar being an island is probably when they made it to those regions and then they broke off. Okay? Most of the persimmons are nocturnal, so they'll have very large eyes, and they're quite a bit different than the anthropoids. Okay? The anthropoids include all the other primates, okay? Monkeys, apes, humans, okay? the great apes, okay? And most of the early anthropoids are extinct. Okay? But we have remnants of them, and we have examples of them that give us quite a bit of evidence that, both groups evolved in Africa and then branched out from Africa. Okay? They both evolved in similar habitats, probably forested habitats, and there's quite a bit of insectivorous pathways. Okay? So they're going to have sharp teeth to begin with. Okay? So here you can see kind of the breaking of the primate evolutionary tree. the persimmons, the lemurs and tarsers, okay, and then the arthropods, okay, which includes the hominoids, and we'll get to the hominoids in a little bit, which includes gibbons, orangutans, gorillas, chimpanzees, and us, and all the precursors, all the extinct species within these groups, which we'll talk quite a few about in the hominids or the human line. Okay, so monkeys themselves, okay, that group of arthropods, okay, is very successful. Okay, and there's lots and lots of monkeys out there. But the monkeys are split even into two main groups. Okay? New World monkeys, and when something is considered New World, okay, we're talking about North America and South America. Okay? In the case of New World monkeys, it's just South America. Maybe there were some monkeys that made it into Central America and maybe touched North America a little bit, but for the most part, South American. Now, there's one way to definitely tell if we're dealing with a New World monkey, and that is they're arboreal still, okay? And they have prehensile tails. Okay? So their tails have the ability to grasp and grab onto branches. Old World monkeys are monkeys that occurred and evolved in Africa. Okay? And there are still some arboreal Old World monkeys, but a lot of them are more ground-dwelling, okay? And none of them have prehensile tails. So next time you go to the zoo and you're looking at a monkey, if it can hang by its tail, it's a New World monkey. It came from South America. If it cannot, it's an Old World monkey. It came from Africa or India region. The hominoids evolved from the anthropoids. Okay, so you have these persimmons. They broke off early, and then you have this anthropoid line, ancestry line that gave rise to the hominoids. Hominoids are comprised of apes and us and our direct ancestors. Okay, so we're actually considered hominids. And that includes humans and all their direct ancestors, which there's quite a few. And for most people, they're a little bit surprised. I always get this question, well, did humans actually evolve from monkeys? No, we didn't evolve from monkeys. We've been, lots of species away from being related to monkeys. Okay, and we'll get to that. There's actually at least, in most people's book, there's at least 6 different species of what we call humans, and we'll eventually get to that and draw some conclusions based on that. So we're not all that closely related to monkeys. We've been separated from monkeys for a very long time. So when we look at the evidence, a lot of the evidence, the early evidence, even evidence that was around during Darwin's time, was fossil, and then just normal like body chemistry and body parts and the arrangement of the organs and things like that. That really gave Darwin a lot of evidence just from examining that we were related to the apes. Okay? But it wasn't really until the 1980s or so that we started being able to analyze DNA. And we started to be able to look at if organisms are closely related, then their DNA should be very close to each other. You shouldn't have as much mutations occurred the closer they are. When we look at Asian apes, like gibbons and orangutans, okay, we can put a general time period on how long ago they separated from humans. And so gibbons diverged first out of the great apes, and that was about 15 million years ago. Then orangutans, about 10 million years ago. And so in general speaking, when we talk about DNA, yes, they're great apes. They're related to us, but we've diverged from them for a very long time. Okay? And so we haven't shared ancestors with them for very long. Okay? But when we look at the African apes, okay, and things that are much closer to humans, okay, the divergence is less amount of time. So 6 million to 10 million years ago, depending on the report, depending on the species that you're talking about also, okay, whether you're talking about gorillas or whether we're talking about chimpanzees. And so they're much closer to humans. And based on genetic evidence, okay, and blood chemistry and protein analysis and things like that, chimpanzees are more closely related to humans than gorillas are. In fact, we think that chimpanzees diverged from the ape line less than 6 million years ago. Most estimates are somewhere around 4 million years ago, maybe 5 million years ago. The chimpanzee line diverged from the ape line. When we look at the genes of humans and chimpanzees, okay, there really hasn't been very much time for them to diverge. Okay, so remember that genes and genetics are subjected to mutations, to random changes in the genetic material that occur over periods of time. The longer organisms have been separated, the populations have been isolated, so human population, chimpanzee population, the longer they've been isolated from one another and not sharing genetic material, the more mutations you should expect, the more of a difference in DNA you should expect. Okay? And depending on the report that you see, and depending on what kind of DNA was analyzed, either nuclear DNA or mitochondrial DNA, it really determines whether or not, what the relationship is. But the least similarity between humans and chimpanzees come at the nuclear DNA at 98.6%. Okay? So there's a 1.4% difference between humans and chimpanzee DNA. Gorillas, on the other hand, we've been separated from gorillas for longer than chimpanzees. Okay, probably somewhere around 8 million years ago. Okay, maybe a little bit less. It depends on the report again. 7 million years in some cases. And it's about a 2.3% difference. Okay? So nonetheless, in both cases, we share a lot of DNA with chimpanzees and gorillas. In fact, we share the same amount of DNA with chimpanzees that tigers share with lions. Okay? And so those lineages have been separated for about the same amount of time as humans and chimpanzees. When we start looking at what ape or what group of apes were most likely the ancestor between apes and hominids, okay, so the human line and the chimpanzee line, okay, we believe that it was probably an arboreal climber. So again, it was an organism that was in the trees, okay, and at home in the trees, and most likely had a heavy diet of insects, but probably also was omnivorous and it could eat plant material. Now, after the apes and the hominids, the human line and the chimpanzee line broke, okay, roughly 4 million, 5 million years ago, when they broke apart, okay, then the hominid line went more bipedal. Okay? So it's not that hominids evolved bipedalism at the exact same time that they broke away from chimpanzee ancestors. They did, however, along the hominid line, and I told you there's lots of hominids, okay, numerous species of hominids. Okay? Along that line, they started developing this ability to walk on two limbs. Okay? Now, chimpanzees, can they walk on two limbs? Yeah, they can. They can walk on their hind limbs. Okay? Are they good at it? No, not comparatively to, say, humans or modern humans. But the feature is still, the ability is still there. Okay? But because we went bipedal, a lot of adaptations had to occur. Okay? You had to have shifts in the actual morphology of the framework that allows for an organism to go bipedal. For example, if you're going bipedal, your hind limbs, okay, our legs, have to be longer than your forelimbs. Okay? Your curvature of your spine needs to be kind of spring-loaded, so our spine went kind of an S shape, which allows for more weight to be pushed down on the spine than, say, something that's curve-shaped, like something that doesn't go bipedal and walks on four. Okay? Shape of our pelvis had to change. Okay? And so you get these adaptations that have occurred over the last 4 million years or so. Apes, on the other hand, that lineage continued or developed, okay, we're not entirely sure, the ability to walk on all fours. Okay? So they're what we call knuckle walkers. So their forelimbs, their front limbs, are actually longer than their hind limbs, okay, which allows them to walk on all fours. The pelvis is a different shape. Okay, the spine is a different shape. Okay, and in general, you just have these varieties, these small, minute changes, okay, but beneficial changes. Clearly, if you're going to go bipedal and you're going to walk on two legs, then you better be good at it and be able to increase speed and things like that. So when we look at it, some of the major differences. Now, these are Australopithecus. Okay, so these are not Homo. This is not the human line yet. Okay, these are the ancestors to both chimpanzees and humans. The Australopithecus would have a hominid skeleton that would show that they had shorter arms, longer legs. Okay, their pelvis is shaped differently, the spine is shaped differently, and the skull is attached on the bottom versus posteriorly. Okay, so you have chimpanzees, or the pan genera, and the Australopithecus genera, which would have gave rise. Australopithecus eventually gave rise to the Homo line, or the Homo genera, which we will get to. Okay, but even when people say, well, did we evolve from chimpanzees? No, we didn't evolve from chimpanzees. We evolved from Australopithecus. Okay? That line. Now, Australopithecus share a direct connection with chimpanzee, or the pan line. Okay? And we'll talk about that in further lectures. Okay? So walking upright, why? We're not entirely sure, but we do know that the habitat around 5-10 million years ago was changing. The climate was changing, and so the forests were being replaced with savannas, so it became much more dry, etc. And we think that probably bipedalism began with the ability, because Australopithecus and the Homo line, really, they were scavengers. Okay? And so it probably had the ability to grasp things and pack things. So the ability to pack food in your hands while walking versus packing it in your jaws and walking on all fours. But it also could have been that because we moved out of the trees and onto the savanna, that walking upright allowed us an advantage to see over the grasslands. So we could watch for predators and things like that. We're not entirely sure. It could have been both. Okay? But we do know that the remaining forested habitat really is where the pan genera, or the chimpanzee genera, maintained, and the savannas is the direction that the hominid genera went. So hominids, again, like I said, include the genus Homo, which we belong to, but it also includes the genus Australopithecus. Okay? Now, Australopithecus gave rise to the Homo genera. Okay? And there's probably lots to be discovered, Australopithecus, and there's lots of Homo. Okay? We're the end of the Homo line, okay? And very, very far away from the pan genera, or the chimpanzee genera, even though we've only been separated for maybe 4.2 million years or so. we still have been separated for a long period of time. So bipedalism probably arose around 4 million years ago. Okay? And we see it in Australopithecus first. And the Australopithecans would have been, bipedal, but they wouldn't have had the massive brain that the Homo line does. And you'll see as we talk about the Homo line that the skull of Homo, that genera, just increases over time. Okay? So it's not the amount of bone or anything like that. The jaw actually starts to shrink and the skull starts to expand, and that is, assumingly that was to house a much bigger brain. Okay? So fossils of hominids, they arose about 4 million years ago before the brain expansion. Okay? And we see this in examples of like the Latola footprints, okay? And we can see it now in fossils that we've found in Ethiopia and other places in Africa. Okay? The brain expansion came after Australopithecus gave rise to Homo genera, and that occurred about 2 million years ago. So walking upright, it's evolved many times, and so this is an example of convergent evolution. Okay, so we're not related to T-Rex or kangaroos or penguins or ostriches. Okay, we evolved this separately from our ancestors. Our ancestors were knuckle walkers, and we became bipedal. Now there are advantages. Okay, speed is one of the advantages. Swimming performance in the case of penguins, but there are disadvantages. Okay? Clearly, you have a bird that can't fly. You have kangaroos that can't climb trees anymore. They're related to koalas, which climb trees, and you have these disadvantages also that comes with walking upright, okay? Including back problems. And most humans realize that they have back problems because it's a lot of weight to put on 2 legs. Okay? And there's an example of the Latola footprints, okay, dated 4 million years ago, and you can see these are primate footprints that are walking upright. So we know bipedalism came prior to brain expansion. So we could walk upright. Our ancestors, Australopithecus, could walk upright before brain expansion, before we had the use of tools or social capabilities and things like that. Okay? All right, so with that, we're now going to move into just the hominid line. So the pangenera and the great apes, we're going to move away from them because there's a lot of evolution with just hominids. Okay? Australopithecus line and then the Homo line, which there's a lot of evidence from just the Homo line of 6 species or 5 species prior to Homo sapien, the species that we belong to. Okay, next time.